in this lesson, we're going to talk about segment lengths within a circle. So we've been talking about all of the angles that you'll see in circles, and now we're going to just talk about tangent lines, secants, and chords. Now, so back to this formula sheet I keep referencing, which is on Canvas. We were talking about the arc and angle measures, okay? So now we're doing the second page, segment lengths and circles. Now, these 5 right here are the same ones on the left hand on the notes. I just put them here so it's like easier to see the examples right next to it, okay? So it all came from this paper. So let's get right to it. So for the first one, it talks about tangents. So for the tangent, it says if your line AB is tangent to circle C, meaning it'll just intersect your circle at one point, then line AB and CD are perpendicular. This line and this segment, actually not line, this segment, they're going to be perpendicular, meaning you have a right angle. So what kind of examples will you see with that? You're usually going to see triangles, okay? So right here, no pun intended, you'll see why. Okay, so I want to solve for x. So for all of these examples, we are solving for x, even though it doesn't say. I want to solve for here. So because, look over here, this line right here is tangent to the circle. It intersects at one point. That means this right here and this segment will be perpendicular. So I'm going to make a right angle. And now we're going to think back on how do we solve right triangles. Now, we're dealing with sides. So we have 2 out of the 3 sides given. So you're going to use Pythagorean theorem. A squared plus B squared equals C squared. So just to review, A and B are the legs, and C is the hypotenuse. So like I always said, across the right angle is my hypotenuse. So right here, this is 3, the length, and over here, this is 4. But I want the whole thing, so all you're doing is adding them. I want the whole length. So C will just be 3 plus 4. So C will equal to 7. Now for A and B, it doesn't matter which leg you choose, as long as C was your hypotenuse. So I'll choose that for A and B. It doesn't really make a difference. So A is 3, but I'm going to square that, plus my other leg, going to square that, equals to my hypotenuse, which we said was 7. So I'm going to go ahead and square that. Alrighty. And now for your operations, you always take care of exponents first. Okay, so this is 3 squared. So just to recap, it's not saying 3 times 2. It's whatever your base is, you're going to multiply it by itself that number of times. So in this case, I'm going to take 3 times 3, and you get 9, plus x squared, which I don't know yet. And then 7 squared is 7 times 7 is 49. Now we're going to go ahead and solve for x. If you see that x squared and you're freaking out about it, don't worry. For now, pretend it's not there. Just write down this step. If this was regular 9 plus x equals 49, you would want x by itself. So this 9 is positive, it's being added to x. You would subtract the 9. And that's exactly what we're still going to be doing for now. We have x squared equals 40. You might think you're done, but you're not, because you want x, not x squared. So remember, we're always doing opposite operations. So in this case, the opposite of a square is taking the square root on both sides. That way these cancel. So you have x equals the square root of 40. Now I know that's not a perfect square. So if you put on the calculator, you are going to get a decimal. And you're going to be getting 6.3245, blah, blah, blah. So in this case, let's just round to the nearest hundreds. And it just depends on what the question tells you to round it to. So nearest 100 means 2 decimal places. I would stop there. Because the 4, it's not 5 or greater, you don't round up. So that means if I put it to the nearest 100, it is going to be 6.32. All right, so next. when you have two tangents from the same external point. So again, tangent means it'll just touch your circle, intersect at one point. That's it. So segment AB touched it once, segment BC touched it once. And they have the same external points. So what happens? If segment AB and segment BC are tangent to circle D, then AB is equal to BC. So that means they'll be congruent. So in other words, whenever you see this cone-looking shape, think of it like a party hat. You know those triangle party hats? When you see that, this is like the face, right? If you see that party hat, that means they're both congruent. And think about it. If you have that party hat, the length on one side is equal to the other length on the other side. So think of it that way. It's a happy face, right? And that's their party hat. So now, we're going to solve for x. So right here, again, I see that looks like a party hat. These are two tangent lines with an external point, so these are congruent. So you're going to set both of them equal to each other. So I have 8x minus 19 equals 5x plus 23. And now I want to solve for x, but there's a problem. I see x on the left-hand side and on the right-hand side. I want them all to be on one side. I always choose a smaller x value to move over. That way I can have a positive coefficient of x. But it doesn't mean you're wrong if you subtracted the 8x. It doesn't matter. So I see 5x is positive. I'm going to move it over, so I'm going to subtract the 5x. So now I have 3x minus 19 equals 23. And now it's your two-step equation. You want to solve for x. Always take care of addition or subtraction. So this one's being subtracted by 19. We're going to do the opposite and add positive 19. When you add those together, you're going to get 42. And the last step is I want x by itself. It's being multiplied by 3, so we're going to go ahead and divide by 3. So x will equal to 14. Okay, next. We have intersecting chords and secants. So secants, if you see that, means it'll intersect your circle at 2 points, and chords means it's just a segment whose endpoints lie on the circle. Again, all these definitions are in that guided notes that you have to refresh your memory on. So basically, when you see that X shape in the circle, even if it extends out, those are secant lines. But if you see this, these are chords because the endpoints lie on the circle. This is what happens. Take the one segment, so AB, this is what you're going to multiply. You can do A times B equals to the other side, C times D. And what's helpful about this is already an X shape. So you think of you're going to be multiplying. You're going to do A times B equals C times D. Okay, so with that being said, we're going to do the same thing here. It doesn't matter which chord you start off with, but I know these are chords intersecting. The endpoints lie on the circle, and we have the X shape. So basically, I'm going to do, okay, so this segment is 6 times 6. That's going to equal to the other segment being multiplied because it's an X shape. Now, you could always multiply in any order. However, if I see there's a variable and just a constant, just a number, I'm going to put the constant in front. Okay, so I have 4 times 5x minus 1. Very important to put parentheses when you have two terms, because that means 4 is being multiplied to both terms. If there was no parentheses, it looks like it's just 4 times 5x, which is not true. Okay, so make sure you put parentheses. And now we're going to simplify. So we have 6 times 6, 36. Now that 4, I'm going to distribute it. 4 times 5x is 20x. 4 times negative 1 will be negative 4. And now, two-step equation, take care of what's adding or subtracting with your x. So that negative 4 is going to be a positive 4 on both sides. You'll get 40 equals 20x. And last step, you're going to divide by 20. So x is equal to 2. Now, sometimes there'll be a question that's not asking you to solve for x. It might ask you, what is the measure of BD? What is the measure of segment BD? So, even if they start off that way, you still have to solve for x first. So, BD is right here. It's this section and that section. So, you're not multiplying them. Just think about the normal segment. If I want to know the whole piece, they give me parts by parts, I'm going to add these parts to find the whole segment here. So, it's 4 plus this right here. But I have x. Well, now I know what x is. It's 2. So, you're going to substitute in your 2. So I'll have 5 times 2 minus 1. So think of order of operations. We're going to go multiply first. So I have 10 minus 1, and that gives me 9. So that means this is 9, and that's 4. So the whole segment is going to be 9 plus 4, and that will give you 13. If you get questions like that, just make sure you look back on what they're asking. You might solve for x, doesn't mean that is your final answer. Next, intersecting secant on the exterior. So it's on the exterior at this point. Secant means it'll be intersecting your circle at 2 points. So this intersects at this point of the circle and here, 2. This right here intersects it here and there. So these are secant lines. Now, how do you do that? So do one side at a time. The outside number times the whole length. So the whole length is meaning you always add them. Like we just said, to find the whole length, you add. Equals to the other outside number times the whole length, and you add. So like for this one, this is secant, because it intersects a circle at 2 points, and so is the other side. Secant, because it intersects 2 points. So you're going to take the outside number times the whole length. The whole length means I need to add them. Equals the other side. The outside number times the whole length. If you want and you want to add it right now, you could go ahead, but I'm just going to show you the steps. Okay, so here you could have already just added it. It would have been 27 if you want to do that. So anyways, next here, we can't combine like terms, so we're going to distribute the 9. 9 times 9, 81. 9 times x is 9x. Now for here, because they're all like terms, let's just work in the parentheses. So it'll be 8 times 27. And let's simplify further. 8 times 27 will give you 216. And now we're back to your two-step equation. Here's my x. I have the 9 being multiplied, and the 81 is being added on to x. So I'm going to do the opposite. It's positive. Let's subtract. So you will have 9x equals 216 minus 81, which will give you 135. And the final step will be dividing, since it's being multiplied. So that could divide out, and you get x is equal to 15. Okay, so I believe we have 2 more examples, and then we'll be done. So now, intersecting tangent and secant. So, if you want to feel like, which one's my tangent? So tangent means there's only one point that it intersects. So that means this is one point, A is the tangent. And on the other side, this is the secant because it intersects it 2 times. So think of secant starts with an S and secant starts with an S, so that's 2. So if you have your tangent by itself, it's right here, you square it and it will equal to the outside number times the whole length. Now, sounds familiar because it's the same thing we did here. These are secants. It's the outside number and then you add the whole length. So, for this one, we're going to solve for x. This is a tangent. It's a shorter part and intersects at 1 point. And the other side is my secant. It has 2 points where it intersects the circle. So, I'm going to square the tangent. And then we're going to go take the outside number, multiply it with the whole length. My whole length, that means I need to add this length. So it's going to be 18 plus x. And now we're going to go up. Whoa, I can't speak. Okay, now we're going to go ahead and square it. 24 squared will be 576. And now for this side, we're going to distribute the 18. 18 times 18 will give me 324. Then 18 times x will give me 18x. And now again, two-step equation. I'm going to take care of addition or subtraction. This is a positive 324. So I'm going to move it over. So x could be by itself. So we have 18x equals 252. And the last step is going to be dividing by 18. So x will equal to 14. Okay, so those are the main 5 examples we'll see for different types of tangent, secant, and chords. And last but not least, it says determine the perimeter of triangle AGN. I want to know the perimeter of this triangle. Perimeter means you are adding the outsides, right, all around. So let's see, at 35, and this part's 21, I'm missing here, 19 missing, and I'm missing here. So we're going to use what we learned to help us find the perimeter. Now, first, let me help you see what it looks like. Let's divide them into sections. What does that look like? That looks like that party hat I was talking about, like the birthday hats. So keep that in mind. And then here, oh look, another one that looks like a birthday hat. And here. The reason why, so anytime, so if a polygon, so your closed figure, is circumscribed around a circle, then all sides are tangents. So, because they all look like it's on the outside, right? The tangent lines, let's go back. When we have that, that means they're going to be congruent always. We have two tangents from the same external point. Same external point for the orange, same external point for the blue and the green. So basically, tangent segments are congruent. Okay, so with that being said, now we just figure out which side is what value. So orange right here, that's the point, 35. So that means this side is congruent, it'll be 35. Right here, this point, this is 19. This side is congruent, is 19. 21 is blue, so this side is going to be 21, because that's the point. And for perimeter, you're just going to add all these values. Now you can go ahead and do 35 plus 19 plus 19, 21, 21. But because I have 2 of everything, I'm just going to multiply by 2. I have 2 times 35 plus 2 times 19 plus 2 times 21. Okay, so now order of operations, you're going to multiply first. I get 70 plus 38 plus 42. And when I add them all together, my perimeter is going to give me 150. Now, no one expects you to memorize every rule that we just went over. No, that's why I have this out, because when you have your questions, the practice questions to do in your assignment, they're not going to tell you the title, which circle is, what kind of segments you have on that circle. So just identify how it looks like. Do you have a set? Do you have a secant, a tangent, chords, etc. Okay, and just practice and have this out with you to help.